On this video, I want to explain the remaining 3 questions. This one up here, it's the same one repeated, accidental, my bad, so we're going to skip that one. Right here on number 2, you want to find the vertex first. And to find the vertex, which is a coordinate, you're going to use the formula x equals negative b over 2 times a. And when you use that formula, you're going to use parentheses instead of the b and instead of the a. So you have negative parentheses over 2 times parentheses. Then you have to identify your a value being 1, your b value is 0 because there is no x term, and your c value is negative 3. If you don't understand that, or if you can't see the b value right there, you should rewrite it as 1x squared plus 0x, because there are no x's, minus 3. Okay, so the a value is 1, the b value is 0, the c value is negative 3. So let's plug in the b value of 0 and the a value of 1, which gives us negative 0 divided by 2, which is still 0 divided by 2, which is still 0. So the vertex x value is 0. And the vertex y value, all you have to do is take the 0 and plug it in to the x. 0 squared is 0, minus 3 is minus 3. So the vertex is 0, negative 3. And if you graph that coordinate, 0 on the x, negative 3 on the y, you end up with the vertex right there, and that's the most important point. Why is it the most important point? Because it's either the maximum or minimum value. Not only that, step 2 is to draw your axis of symmetry right through that most important point we call the vertex. Also label it axis of symmetry. So we have the most important point, we have the reflection line called the axis of symmetry. We just need more coordinates. So we could jump to an XY table and plug in some other points to get out answers to reflect it to the other side. Or we do have the a value of 1, which means that we could use the pattern 1, 1, 2, 4, 3, 9 from this coordinate. So the a value is positive, so it's going to be opening up. And let's use the pattern 1 over 1 up to get this coordinate. And then go back to the vertex and go 2 over 4 up to get that next coordinate. And then go back to the vertex and go 3 over 1, 2, 3, 9 up. And we're 1 unit off the graph, but that's okay. I want to draw that dot even if it's off the graph, just to get a better accurate graph when I graph it. So let's map the coordinates over to the other side of the axis of symmetry. 1 unit away, go 1 unit away, and put the dot right there. The next one, it's 2 units away, go 2 units away, put a dot right there. And the last one is 3 units away, so go 3 units away and put a dot right there. And we are off the graph. So just connect those dots. And I put those dots out there so you could point your arrows towards them. You don't actually have to draw it off the graph, but I put the points there so you could point the arrows towards them. And that's your perfect graph right there. You didn't even have to do this XY table or plug in any numbers. You could have used the table if you don't want to use the pattern. Could we use the table on this guy? 1, 1, 2, 4, 3, 9? No, the a value is not 1, unless you modified the table with that new a value of 3, right? But let's not modify the pattern. Let's just find the vertex and let's plug in some points with the XY table. So again, the vertex is a coordinate, an x value and a y value, and the vertex formula is x equals negative b over 2 times a, and we use parentheses instead of the b and the a when we plug in values. And we look at our a, which is negative 3, our b, which is negative 6, our c, which is 2, which we don't use on the formula. And we plug in the negative 6 for b and the a value of negative 3. So we end up with x equaling a positive 6 up on top over a negative 6 on the bottom, and that equals negative 1. So that's our vertex x value, negative 1. If I want my y value, I have to plug in that negative 1 into my x's on the actual standard form quadratic function. Okay, so I'm going to rewrite this whole thing, but instead of x's, I'm going to put parentheses. In other words, y equals negative 3x squared minus 6x plus 2. Notice I put parentheses instead of x's. And then I'm going to plug in the actual value of x, which is negative 1, right into those parentheses. Then I do PEMDAS. Negative 1 squared, that's positive 1. And of course, you still have this negative 3 out here. So negative 3 times positive 1, that's negative 3. And then 6 times negative 1, that's negative 6. But with the minus sign in the front, that's a negative 6, which is a positive 6. Or you could have thought of it as negative 6 times negative 1. That will give you a positive 6. And then you bring down the plus 2 at the very end. And then just go from left to right. Negative 3 plus 6, that's 3. 3 plus 2 is 5. So the y value of our vertex is 5. That's the most important point on this parabola that opens down, that's kind of narrow because the a value is 3, negative 3. So let's go to the coordinate negative 1, comma 5. Negative 1, 5 is 1 on the x, 5 on the y. That's way up here, negative 1, comma 5. Second step is to draw the axis of symmetry right through that vertex. It's a vertical line. We always do it dotted. Let's label it axis of sym. Now we need more points. So we could modify the pattern 1, 1, 2, 4, 3, 9, or we could use just an XY table. Let's just use an XY table on this one. So which X value would be good to plug in? Somebody give me a number to plug in. Do you think 5 would be a good number to plug in? Negative 4 would be a good number to plug in? How about this? Whenever you have your vertex, use a coordinate that's close to your vertex, or use an x value that's close to your vertex x value. So negative 2 is good, but even easier than that would be 0, right? Let's actually plug in 0 for our x. Plugging in 0 for our x, let's see what it gives us for y. So plug in a 0 there and a 0 there, everything becomes 0. 0 plus 2 is 2. So when you plug in 0, you get out a 2, and that coordinate 0, 2 is right there. And from there, you could just map it over to the other side, and you have your parabola already. Now, of course, you want to make that parabola a little bit bigger. So what other number would be good to plug in? 1 would be excellent. Let's plug in a 1. 1 squared is 1. 1 times negative 3 is negative 3. 6 times 1 is 1. Negative 3 minus, 6 times 1 is 6. Negative 3 minus 6 is a negative 9. Negative 9 plus 2 is negative 7. So when I plug in a 1, I get out a negative 7. Let's graph 1 and negative 7. I'm off the graph already. So I want to put the 1, negative 7 down here, even though it's off the graph. I'm not going to graph it all the way down here, but I know to at least point my arrow going towards this dot. So I'm just going to draw my parabola, and I want to put an arrow going towards that dot right there. Now I want to map it over to the other side over here as well. That way, when I continue with this, I know to draw an arrow pointing towards that dot down here. Yes, but that's a perfect parabola right there. And we didn't use a pattern. We just plugged in numbers, pulled out answers, and mapped it over the other side of the axis of symmetry. Number 4 is a fraction. This one's really, really, really ugly. Okay? This is as hard, as horrible as it gets. Let's find the vertex. The vertex, you're going to use the vertex formula. X equals, it's going to be a coordinate, x and y. X equals negative b over 2 times a. You're going to go negative parenthesis over 2 times parenthesis. The b value is 2. The a value is negative 1/3. So when you work this out, you're going to get x equals negative 2 divided by negative 2/3. Now this is really weird because it's written vertically, negative 2 divided by negative 2/3. Let's write it horizontally. In other words, negative 2 divided by negative 2/3, that really becomes a multiplication problem. So you'll have negative 2 times negative, but flip it over 3/2. When you divide by a fraction, you could multiply by the reciprocal by flipping that fraction. So a negative times a negative is a positive, and the 2 cancels with the 2. So a negative times a negative is a positive, so your x value really is positive 3. I hope that makes sense. Yes. When you divide by a fraction, you really multiply by its reciprocal. So the x value is positive 3. In order to find the y value, you have to plug it in. And here's where it gets really ugly. Because let's rewrite that function, y equals negative 1/3 x squared plus 2 times x plus 3. And let's plug in the x value of 3 right there and right there. So when we do the math, 3 squared, that's 9. Now, actually, it worked out pretty nice, because when you multiply 9 times negative 1/3, I thought we were going to end up with a fraction, but actually it works out nicely. 1/3 times, negative 1/3 times 9, if you do that on the calculator, it'll give you a negative 3. Okay? You could, if you wanted to show it, put 9 over 1, and then you could cancel the 9 with the 3. You'll get a 3 left over. So negative 1 times 3 is negative 3. And then 2 times 3 is 6. So we have a plus 6 and then a plus 3. So when you do the math, negative 3 plus 6, that's 3, and 3 plus 3 is 6. So our vertex is 3 for x, 6 for y. Let's graph that. 3 on the x, 6 on the y. That's going to be 1 unit off already. So this is ugly because the vertex is already off of the parabola. I mean, off of the parabola, off of the graph. I should have put a 10 by 10 graph so I could fit it in here. But anyway, the vertex is off of this graph. I'm still going to draw my axis of symmetry right through it. Now, I need more points. So for more points, I'm going to use the XY table. And I'm going to plug in values. Now, if I were to plug in the number 0, that's kind of not that far away from the x value of the vertex. So if I do plug in 0, what do I get? 0 squared times 0 is 0, times 2 times 0 is 0, 0 plus 0 is 0, I get a 3. So when I plug in 0, I get out a 3. Let's actually graph that 0, 3. 0 on the x, 3 on the y, there it is. Okay? If I map it over, it's 3 units away. So 3 units away will take me 1 unit off of this graph, but who cares? I want to put it right there. And ladies and gentlemen, technically this is my graph. It's pretty wide. And why is it wide? Because the a value is closer to 0. It's negative 1/3. So that's why it's wider than usual. Would it be a good idea to plug in more points? You could if you wanted to. But because this is a weird graph already, I'm just going to put some arrows on it and we're done. So I hope you guys finished this assignment and understood it.